Alright, so now when you're taking antiderivatives, it's good to remind yourself or keep a list of the antiderivatives that we know. And so let's just, the way to do this is to think about what the table of derivatives is. So if you have f and f prime, we can go ahead and take our table of antiderivatives, and when we take our antiderivatives, we'll use capital F for the antiderivative. Okay, so just as an example, um, we had like a c and then we had 0, right? And then x to the n is n x to the n minus 1, and e to the x is e to the x. And so if we go backwards, right, normally we wouldn't just be given 0, right, because you would just be given a blank. But this is the plus c, right, that you would add on to your end, the end of your antiderivatives. Oh, my computer's dinging. Something must be done. So how would I take the antiderivative of x to the n? So go ahead and flip this table around, and instead of subtracting 1, we would add 1, right? And then in the front here, I need something to multiply by, so when I bring the exponent down front, they cancel, right? And so I would have that. But before we finish with this formula, notice that that doesn't work for if n is equal to minus 1, right? And so if n is minus 1, that leaves you with a 1 over x here. Now in this table, is there a function whose derivative is 1 over x? Oops, I see it over here. Do you remember that from the last video? Yes, that is the natural log. And in fact, we should go ahead and just say it's the natural log of the absolute value of x, unless there's a reason to distinguish it, because this really gives you both positive and negative numbers, right? So the only number this is not defined for is x equals 0. Good. So these kind of go together, right? And then e to the x is just going to be e to the x again. What else do we have? The trig functions. So we have sine of x, cosine of x. So the antiderivative now is going to be minus cosine of x here, right? Because the derivative of cosine is negative sine. And then the antiderivative of cosine will just be the sine of x. Okay. Now I'm going to put tangent in the column here later on. For right now, let's go ahead and use our other derivative formula. So here we have secant squared x. So the antiderivative will just be tangent, because the derivative of tangent is secant squared. And then if we have secant x tangent x, what function has the derivative of secant x tangent x? It is the secant of x. Very good. So we'll keep those as kind of our basic antiderivatives for now, and then we'll get more complicated in calculus 2. Let's see, we had a couple more that we want to remember, and that was 1 over the square root of 1 minus x squared. So again, in the original derivative table, if we have 1 over the square root of 1 minus x squared over here, what was over here? Do you remember? Yes, that was the arc sine or the inverse sine of x. And so similarly, 1 over 1 plus x squared is the inverse tangent of x. And so those are the two we want to remember from that. Good. Now there's one other thing I wanted to talk about for antiderivatives, and that is, let's see, maybe we'll look at the derivatives first. So in the derivative table down below here somewhere, you're going to see the derivative of a constant times a function is a constant times the derivative, and let's see, the derivative of a sum or difference is the sum or difference of the antiderivatives. And so over here then we should also write for generic functions, if I have a constant times a function, the antiderivative is going to be a constant times the antiderivative. And to anti-differentiate a sum or difference, we will take the sum or difference of the antiderivatives. Good. And so this table right here, which we can't see all in one screen, sorry about that, is our table of antiderivatives that we want to remember. I'm going to put this on the class website at some point. For now, though, you might try to use flashcards for these antiderivatives so you don't have to keep checking back to the table. All right. So let's try another example here now that we've had a little taste of our table. Oops, why can't I go from here? Oh no, okay, we'll go from here. So suppose that f of x is equal to the square root of x plus 5 minus 4x squared plus x cubed divided by x to the fourth. Find the general antiderivative f of x. Okay, go ahead and pause the video if you want to try that yourself, and in a second we'll pick it up from here. Alright, so the idea here is that I would go ahead and rewrite this using some algebra. And so square root of x is x to the 1/2 power, and then this is going to be 5 over x to the fourth minus 4x squared over x, I guess we could just go ahead and write that like that, yeah, plus x cubed over x to the fourth. And so just rewriting that, and notice that we're just using algebra so far, we're not using calculus. X to the 1/2 power plus 5x to the minus fourth power minus 4. Now 2 of those canceled with those 2, bring this up and you get x to the minus 2 power, right? Plus 1 over x, or x to the minus 1, well, we can just leave it as 1 over x. Good, as a little hint. So now we can anti-differentiate everything in sight. So instead of taking away from 1, or taking 1 away, you add 1 to the exponent. So we have 1/2 plus 1. Let's go ahead and just add that, because that's 1/2 plus 2/2 is 3/2. Because you want to add that first and then put the constant out in front, because you reciprocate that, plus 5 times, leave a little space, x to the, now add 1, so that's going to be minus 3. So this is going to be minus 1/3, right? And then minus 4, and then leave a little space, x to the minus 2 there. Oops, x to the minus 1 there. And so this is going to be a minus 1, and then plus the natural log of x, and then plus c. All right. So now we can simplify that a little bit. 2/3 x to the 3/2 minus 5/3 x to the minus 3 plus 4x to the minus 1 plus the natural log of the absolute value of x plus c. Good. Now, unless we're looking for the most general antiderivative, you don't have to put the plus c1 for positive and plus c2 for negative. Okay, otherwise you can just put, say, a plus c for the generic antiderivative. Very good. All right. So let's try a few more problems. And I actually want to define something here. Definition find, or given an equation with y, y prime, y double prime, and so on. You don't have to have all the derivatives, but you might have a few derivatives. The equation is said to be a differential equation. And differential equations, the unknown is the function y. So for example, you might have like y prime is equal to 3x plus 1. And we already know how to work with this one, right? So this is called a differential equation. A differential equation because it's an equation that has the function here. And so in this case, you can solve for the y by taking the antiderivative of both sides, right? So this would be 3, this is x to the 1 power, so we'd write x to the 2 power for the antiderivative, put a 1/2 in the front, plus, and then the antiderivative of 1 would be x, right? X to the 1 power, because again the derivative of x is 1, plus c, and so you would write y equals 3/2 x squared plus x plus c, right? And so you're able to find the unknown function given the derivative. So we've just solved this differential equation. Good. So in the next video, I think we'll just do a bunch of examples that are similar to things that you'll see in the homework. See you then.